In the previous video, we looked at how many different ways we could order the ingredients in our BLT, uh, and then later BLT MA. Here, let's assume we don't care the order of the ingredients. So this may be more, we're making a pizza, although I would say there are some places where they put the onion right underneath the cheese. It's really good. But let's say the place we're ordering from, all of the ingredients go on top, and we are trying to decide what toppings we want. So our math changes a little bit in this case because some of the different combinations would be redundant or duplicates of the order. And so let's think about, so let's say we're trying to decide, we have 5 options that all of us kind of agree that we like, but how do we select? Let's see, we're not willing to shell out for all 5 toppings. We only want to have a 3-topping pizza. Okay, and maybe we'll randomize it, maybe we'll argue for 20 minutes, but somehow we're going to come up with a 3-topping pizza. How many different options do we have? Well, we could have, selecting these, so we could have onion, pepper, and a mushroom. Okay, we could have now compare this to in the previous video. I want to highlight that we could say onion, mushroom, pepper, but in this case these are the same, right? Because we don't care about the order, these 2 options are going to be the same, and so we can't write them both down. Okay, so once we've chosen onion, pepper, mushroom, the other options are redundant. Okay, so other options, though, we could have onion, pepper, and sausage. We could have onion, pepper, and anchovy, and continuing on, we could have onion, mushroom. We can't do pepper, but we could do sausage, and so on. Okay, so how do we quickly calculate this, again, without getting bogged down in writing down however many there are, and we're going to calculate how many there could be here. So how do we go about doing that? Well, we need to take into account, or we can build it off of our last formula. Okay, so it's going to look very familiar. The combination formula, and here that's what we're worried about. We don't care the order, so it's just combinations of different ingredients. It's going to rely on the same concepts here. So we are choosing 3. So in our case, we're choosing 3. I'm gonna just actually put up the permutation formula. I gotta find this. Okay, so I just want to compare across these 2. So notice it's very similar to what we just did, but here we have an extra little thing on the denominator, and so we'll talk about the logic of why that exists. Okay, so when we want to choose, and the way we refer to this is one way to talk about it is n choose r. Okay, so we have n objects, and we want to choose 3 of r of them. And so, what's going on here? So we do the same thing we did with the permutations. Okay, so we have n factorial on the top. So in our case, actually, let's just work through it here. So in our case, we would have 5 choose 3. Okay, and that's going to be 5 factorial. Right? We're indicating that we're still counting up that there are 5 factorial different orders that these could go in. Okay, and if you remember from the last video, that's 120. So there are 120 different orders of which we could put all 5 of these options. But what we're going to take into account is we're going to make sure that we're crossing out, right, some of these redundant ones. And the way we're going to do that is to divide by 3 factorial, and then of course the same thing we did previously, which was 5 minus 3 factorial. Okay, and so this 3 factorial in here takes into account all of those redundant options as far as ordering them. Yeah, so when we calculate this out, it's 5 factorial over, well, we can simplify this a little bit, 5 factorial over 3 factorial times 2 factorial. Okay, and so we could just calculate that directly, or we can say this is 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. Okay, so in some sense these cross out, and we have 20 divided by 2, so we end up with 20. Okay, so there are 20 different 3-topping pizzas that we could make from these 5 items. And so you can see the permutation and the combination formula are very similar, and really the combination formula, again, what it's going to do for us is eliminate these redundant, right? So these are redundant options because we don't care what order they are in. Okay, so what this is highlighting is that we're going to have to be pretty careful in terms of what we care about when we approach a problem. It's going to matter if we care about the order or not. And so that's one kind of word of caution as we move forward, is that those specifics are going to really change our answer, right? So in this case, it's 20 compared to 60, or 20 compared to 60 compared to 120. And so that's something to note, is that, yeah, just be mindful of what we actually care about.